Solutions&Colligative.com.
Okay, students, today we are going to solve some previous year questions. These are extracted from 3 exams, NEET, Mains and Advanced. Okay, so and wherever extra information is required for solving the present questions or future questions, that I will explain with the tricks and detailed explanation. Okay, so let's start one by one. Wherever you feel that that question I can do, just you have to pause it and solve it. Okay. So here comes the first question. At 300 Kelvin, vapor pressure of ideal solution containing 3 moles of A and 2 moles of B is 600 torr at the same temperature if 1.5 moles of A and 0.5 moles of C. See, there is a change in the solute. Okay, here moles of C added to the solution, vapor pressure of solution increases by 30 torus LE. So, what is the value of P naught B? Okay, take your time, but you should not miss your accuracy. Slowly, we will work towards the increasing accuracy and decreasing the time. But in the first question, you may take time. Okay, now listen to my explanation. This much time only will get in examination. Accordingly, you have to devote. So here it is given that at vapor pressure of solution when 3 moles of A and 2 moles of B is 600 torr. Okay, 600 torr means here P solution is equal to P naught A into XA plus P naught B into XB. But problem is that P naught A and P naught B is not given. And okay, so P solution is given as how much? 600 is equal to P naught A we don't know. P naught A we don't know. So XA will be 3 moles of A divided by 3 moles of A plus 2 moles of B. Same way, P naught B into 2 by 3 plus 2. Okay, so this will be one equation. So let us take as this as a first equation. Now, after that, what happened? Uh, P solution is increased by, see here it is increased by 30 torus LE. So this will be 630. P naught A will remain same, okay? And C is a non-volatile, so its pressure will be obviously 0, okay? But moles to be considered. And 1.5 moles of A added, not present. That means it will be 4.5 divided by 4.5 plus 2 and C moles are 0.5. Okay. So same way P naught B. Again it will be P naught B. Moles of B is remaining as a 2 only. So T2 divided by 4.5 plus 2 plus 0.5. So on simplifying, we will get something like this. So answer will be C. How it is, detailed answer is here. Just check it. Okay, see completely detailed answer. Okay, now let's go to the next question. Okay, next question is exactly 1 gram of urea dissolved in 75 grams of water. A solution boils at, okay, water means you can take it as a boiling point of solvent, okay, as a water only. Understood? Now, here next what is given, that means this is changed here. This is T solution, TB solution. At 760 torr is 1 atm only. So once it is 760 torr only, 1 atm only, you can take 100 degrees as a boiling point. Molecular weight of urea you can to take 6.60.1, then boiling point elevation constant. KB is question mark. Okay. Okay, it is very simple question. Delta TB is given. What is given? Delta TB will be 100 minus 100.114. This is delta TB. Okay. Now delta TB is given. KB you have to find out for molality. Mass of solute 1 divided by molecular mass of solute 60.1 divided by mass of solvent 75 into 1000 because it is in the grams. Okay. And as it is a urea is a solute which neither dissociates nor associates. So I is equal to 1. Okay. So when you substitute and solve for the Kb, you will get 0.51. Is it understood? Okay, next questions. These are all AIMS question. You can understand in the 2009, we got in AIMS question, first question, that much difficult. Okay. So an aqueous solution of NaCl shows NaCl means you have to consider it as a non-ideal. It is dissociating. Okay. So students ask, sir, when we will take I and when we will not take I. That depends upon the solute. Okay, here this is the rare question where you have to use two concepts. What are the two concepts? Boiling point and freezing point. The two, freezing point of NaCl and boiling point of BaCl2. But only common thing is same molality. Okay. So in that case, what you will say, suppose freezing point, delta TF of NaCl delta TF of NaCl and boiling point of delta TB of BaCl2. When you take the ratio, lot of the things will get cancelled automatically. So therefore, Kf into molality, this numerator is about the NaCl and denominator is about the BaCl2. Okay, denominator is about what? BaCl2. Understood? Now Kf is given as 1.86. Okay, and molality you need not to take anything, and I value, sorry, I value I forgot, I into. Okay, so I value for NaCl will be 2 divided by Kb is 0.52. I value for BaCl2 is 3. BaCl2 composed of 3 particles, therefore 3. NaCl composed of 2 particles, so 2. Okay. Now, and here what is given? Boiling point of the uh, depression in freezing point is given. Okay. So 0.372 divided by delta TB. Okay, this is just idea. So complete detailed solution I am going to show you. So this is a complete detailed solution. On simplifying delta TB, we got it as 0.156, but that is not answer. Boiling point of solution. So 100 plus 0.156, 100.156 is the answer. Okay, let's see which option is suitable for that. Okay, so 0.1, see here, so much confusion in the examination during the tension hours. This will and this will create a problem. Answer will be D, 100.156. 100.156 is the correct answer. Okay, now you can check with the next question. Okay, here 12 grams of urea dissolved in 1 liter, 68.4 grams of sucrose dissolved in 1 liter. So lowering of vapor pressure of first solution, that is urea solution lowering of vapor pressure, okay, is equal to the sucrose or greater than sucrose, less than sucrose or double than the sucrose, okay. Answer to this question is A. Okay, equal to the second. Simply both you find out lowering of vapor pressure. Okay, so P naught solvent minus P solution. P naught solvent minus P solution, and urea NH2CONH2, sucrose is C6, sorry C12H22O11 342 or 344. 342. Okay, so like that, if you substitute, you will get the equal to the second. I think it is easy question, need not to explain much. So let's move on to the next question. Okay, now next. At particular temperature, vapor pressure of two liquids A and B respectively, 120 and 180 mm of mercury. If 2 moles of A and 3 moles of B mixed to form ideal solution, vapor pressure at the same temperature will be. Simple question, speed matters here. Okay, here. Very simple question. You are given with mole fraction. Okay, with the help of moles, you have to find out the mole fraction. Okay, 2 by 2 plus 3 plus pure liquids, vapor pressure of two liquids A and B. Okay, then we have to find out solution. Answer will be 156. Mole fraction will be 3 by 2 plus 3. Okay, now let us see the next question. For this question only in our one shot, I have given you one short trick without doing anything. Okay, because delta TB, delta TF. That's why I request all of you to go through till last. Okay, so don't lose your patience after 15 to 20 minutes, because best thing comes when we wait till last. Understood? So according to that, I have told you colligative property directly proportional to Vanta factor, inversely proportional to molecular mass, and some more tricks are there. Okay, so you have to check with them. Understood? Here nothing is given equimolal. That means you need not to worry about molality. You have to worry about equivalent factor and molar mass. Okay. So when you consider both of them, like NH3Cl, for this I value is 2, here I value is 3, here I value is 3, here I value is 1. Okay, freezing point highest. So for this is also one of the main problem. Freezing point highest means delta TF must be lowest. Delta TF must be lowest. Okay, so delta TF must be lowest means either I should be lowest and molar mass should be highest. Okay, now if you consider both the points, the D option will be the suitable, because it got only one. I is equal to 1 and molar mass is considerable because rest all are 3 times. Molar mass is not 3 times smaller. Okay. So directly blindly you can go for the D option. Okay. So let's go for the next question. Okay, next question, read and start fast. Which of the following 0.1 molal aqua solution have lowest freezing point? Similar question. So I think you will time consumption will be very less for this. So molality same, lowest freezing point means highest delta TF. Lowest freezing point means highest delta TF. Okay. So delta TF should be higher so that TF should be lower. So delta TF higher means I value you should consider mostly. Okay. So here Al to SO4 whole thrice I value is how many? 5. And here it is 1 and here it is 2. I don't think molecular mass will play a major role. Major role will be I value. I value highest, so del TF will be lowest. So answer will be A. Okay. Now let's see the next question. Next question somewhat calculation. So I will give you time. You can take time, but don't lose accuracy because of the silly mistakes. Okay, here solution containing 10 gram per dm cube. Dm cube means 1 liter. Okay. Isotonic, hypertonic, hypotonic. These topics are clearly explained. And there is one more problem. Okay. Exosmosis, endoosmosis, crenation. These are all explained. Okay. Direct question will be there. Exosmosis, endoosmosis, and crenation. Okay, crenation, what is crenation? That is one shot explained. Go through that. Isotonic means osmotic pressure of urea is equal to osmotic pressure of some unknown solute. Okay, unknown solute S. Understood? Find molecular formula. Simple and it is a non-volatile. Okay. So molecular mass you have to find out. Simple moles must be same. 10 divided by 60 is equal to 5%. So 5 upon 100. Okay, 5 upon 100. And molecular mass we don't know. 5% means 5 grams of solute and 10 grams per liter. So this will be 10 moles divided by volume. Okay, 1000. 5 divided by molar mass. On simplifying, people are getting 300 and that is very correct. Okay, now let's go to the next questions. Okay, next question. Okay, next question. Vapor pressure of solvent here. These are the very problematic words. Decreases by, that means whatever the value is there, that much be reduced. Don't take this as a final. When non-volatile solute more fractional solute is 0.2. So decreases by how to convert it into the solution equation form. P naught minus PS is equal to 10. Okay. X solute is equal to 0.2. What should be the mole fraction of solvent to decrease? P naught S, sorry, P naught minus PS is equal to 20. Then what is the mole fraction of solute? Question mark. Okay. Okay, this is wonderful, tricky question, dangerous. Here they have given you lollipop in the form of this. Mole fraction of solvent. Here you will get mole fraction of solute. Okay. So mole fraction of solute will be 0.4. I also agree. So, but you should not take this one. You should take B. Why? Because the sum of the mole fraction is equal to 1 and mole fraction of solvent minus 0.1. Okay. So solvent will be 0.6. So these are the very, very important traps. Okay. Don't get into the trap being which chem student. Okay, solution of urea, molar mass 56 grams, boils at 100.18 atmospheric pressure. Kf and Kb both are given. Above solution will freeze at. So I will tell you the shortcut here. Molality is not given and you need not to find out also because same solution. So delta TF upon delta TB will be as same solution. Ki will be same. So Kf upon Kb. Okay. Kf upon Kb. That ratio, depression and elevation will be in the ratio of Kf upon Kb. And we are interested about the freezing point. That's why I have to keep the delta TF in the numerator. So delta TB into Kf upon Kb. Kf, Kb both are given. Delta TB is also given. On substituting, you will get 0.654. See how the cruel people here. Immediately people start answering as 0.654. So this much decrease, okay? So answer will be minus 0.654, okay? Freeze at, if the question is what is the depression freezing point, then answer will be 0.654. What is the freezing point, then answer will be minus 0.654, okay? Next, a solution containing 1.8 gram of compound, empirical formula. 40 gram of water freezes. What is the molecular formula? Simply you have to find out the molecular mass, then you will find out n factor, then you will multiply with that, then you will get the molecular formula. Okay, when you solve according to the molecular mass, you will get, first of all, molecular mass, you will get 180. 180 divided by empirical formula. Empirical formula mass will be 30. So it will be 6. So N factor C6H12O6. So D will be the correct answer. So this is a theory question, but combined 3 questions to give it as a 1 question. So correct options are A, B, C, D, not 1, 2, 3. So solve all the 3 questions, then answer from A, B, C, D. Okay, answer to this question is D option. Colligative property depends on number of particles. Methanol is a non-volatile solute, hence cannot be considered. Okay, so what is the correct answer? D answer is the correct answer. Okay, so D answer is the correct answer. Pure water freezes higher temperature than pure methanol. Okay, you cannot consider because methanol is non-volatile. Okay, non-electrolyte. Sorry, not. I am not saying. Not non-volatile, it is non-electrolyte because if it dissociate into ion, then I value you can say, but it will dissociate or will form the hydrogen bonding that we don't know. That's why as a molecule we cannot say. Okay, so answer D is correct. Okay, here he given ideal solution. That means he is asking you to use Raoult's life required. Equimolar, so molarity is same. Binary, two compounds are there, A and B. Vapor pressure of torr, 45 torr. This is the vapor pressure of solution. Okay, a new solution of A and B having XA and XB respectively has vapor pressure at 22.5. Then value of XA upon XB in the new solution is, okay. So P naught A is 20 and P naught B is not given. Vapor pressure of pure liquid. Okay. So here I am writing it here. P naught A is given as 20 torr. P naught A is given as 20 torr. Okay. And XA is equal to half of XB. Okay. XA. Why it is? Because equimolar. In the first solution, it is given as equimolar. So mole fraction will be same. Okay, XA is equal to XB will be equimolar. So it will be 1 by 2. Okay, so you can substitute here 1 by 2 into 20 P naught A. Okay, plus 1 by 2 into P naught B, we don't know, is equal to how much it is? 45. Okay, by using this P naught B, you can find out once you know the P naught and P naught B, you can substitute in place of XB, you can take as a 1 minus XA. So one equation will be there and one value you have to find out. Then divide both of them. Okay, answer you will get 19, 19. So 19.00. Answers you should circle is 19.00. Okay. Okay, next question. Mole fraction of a solute in solution. Solute in solution at 298 Kelvin. Okay, molarity of solution. Molarity of solution is same as molarity. Actually, in elevation and boiling point and freezing point, you will take molarity. So molality, but you is saying molarity, you can use it. Okay, density of the solution is 2. Then ratio of molar weights of solute and solvent you have to find out. Okay, here it is. We have to find out the ratio of molecular mass of solute divided by molecular mass of solvent. Okay, answer to this question is 9. And how it is? Detailed explanation. Let us see. Okay, this is the detailed explanation. Molality is equal to, this is a direct formula, mole fraction of solute divided by mole fraction of solvent into molar mass of solvent. Okay, this is solvent into 1000. Then we got the molality, and molarity is simple. This is density. Okay, we can write it as a 10 also. 0.1 into 2 into 1000 divided by zero point 0.1 into molar mass of solute plus 0.1 into molar mass of solvent. So just by equalizing them, you will get the ratio of molar mass of solute divided by molar mass of solvent. It is equal to 9. Okay. Okay. Next question: a compound H2X with molar weight 80 gram in a solvent having a density 0.4 gram per milliliter. Assume no change in volume upon dissolution. Then molality of 3.2 molar solution is. Okay, here normally solute is very less in quantity, and in numerator also we will not take mass, we will take moles only. So by considering that V solution, if we take it as a solvent, 1 liter of solution, here it is given 3 moles of solute. Okay. Solution and solvent, if it is same, so volume of solution is equal to volume of solvent. So here volume of solvent, if it is 1 liter, density is given as a 0.4. So 0.4 kg. Okay, so more mass of solvent is 0.4 kg and moles of solute is 3.2. So 3.2 divided by 0.4, you will get 8. Okay, answer is 8. Now let us do some easy questions from the mains. Okay, answer is 10 ppm. This is just a memory based, okay, from the other chapter. So 10 ppm. Now start solving the next question. Okay, here simple question. You are given with 8 grams of NaOH. 8 by 40. That will be the moles of NaOH. 18 grams of H2O. Very famous, 1 mole. Okay. Mole fraction of NaOH and molality. If you find out, you should get this answer. Some student by mistake getting D answer also. So check what went wrong. Okay. Okay, next question. Amount of cane sugar required to prepare 2 liter of zero point 0.1 molarity aqueous solution. Speed up, very simple question. It was like a cakewalk for the 2019 main student. Okay, answer is direct formula based, so need not to explain, I hope. Answer is 68.4. Now start solving and answer with second and answer. Okay. So elevation and boiling point of 1 molar solution is 2. Okay. Then depression freezing point of 2 molar solution is 2K. The relation between Kb and Kf. Simply delta Tf by delta Tb. Similar question we have done in the advance. Aims, I think. Kf by Kb. Okay. And molality is same. Molality 2 molar solution. Here for freezing point it is 2 molar solution. Okay. For freezing point. Okay, 2. And for boiling point it is 1. So by simplifying you will get 2 Kf. Kb is equal to 2 Kf. Okay. This is 2 Kelvin. Okay, this is 1. So answer will be 2. Okay, 2 Kb is equal to 2 Kf. So Kb is equal to 2 Kf. That means which option is correct? B option is correct. Okay, next question is here. Which one of the following statements regarding Henry's law not correct? Very dangerous question. Read it carefully. Okay, here question is not correct. Question is about what? Not correct. Okay. Answer is B. Higher the value of KH at given pressure. Higher actually KH and solubility inversely proportional. KH and solubility are inversely proportional. Okay, now solve this question, very important. Okay, here sodium ion mass is given and water mass is 1 kilogram. So you will get easy question 4. Okay, what is the answers? 4. Now let's see the next question. Understand the graph very carefully. Okay, see in this question, you have to make your own equation. Okay, according to Henry's law, partial pressure is equal to Kh into mole fraction of solute. So this is mole fraction of solute. But here if you cross check with the x-axis, you are getting mole fraction of water. Okay, it is what? Mole fraction of water. That means you have to change this equation according to mole fraction of water. So then we are getting something like this equation. To give it into mole, to give it into the y is equal to mx plus c form, one thing you can find, mole slope is negative. That means line should go at the down, and intercept is directly proportional to kh. So wherever kh value is higher, okay, that intercept should be higher. Okay, so here you can see k 40 k bar. Okay, this is for z. So z should be on the top, then 35, y should be the second, and 2, so x and w, okay. Then negative slope. So all the things are matching in the C option. How to go to this conclusion? I think it is clear now. Okay, next is a lengthy question, so read it carefully. Okay, answer to this question is D option. What is the answer? D option is the correct. Okay, 500 mm of Hg, 0.4 comma 0.6 mole fraction. Okay, very simple. Those who are doing silly mistakes, some minute problem, they are getting this answer. You should consider the mole fractions also. Okay, 600 and 400. Okay, here it is in the vapor phase. Vapor phase you will use Dalton's law. Okay, in the Dalton's law, P solution will become as a P total. P solution will become as what? P total. Okay, and PA is equal to that we will extract from the Raoult's law, P naught A into XA. PA is equal to P naught A. So that we will use it here. So P total into mole fraction of, this will be mole fraction of A in vapor phase, which is what we have to find out, and PA. Okay, so by using that you will get 0.4 and 0.6. Okay, next question, speed up. 1 molar aqueous solution of following compounds, which one will show highest freezing point? Molality is same. This is related to coordination compound also. Okay, so highest freezing point, that means delta TF. Delta TF must be lowest. Okay, delta TF must be lowest. So delta TF lowest means I should be lowest. Okay, so delta TF must be lowest to have the freezing point highest. So delta TF means I should be lowest. Okay, I will be lowest. See, for this only one bracket. Here 2 chlorine and 1 R. Here it will be 4. And here it will be 3. Here it will be 2. So what is the correct answer? Okay, here A will undergo minimum depression. So maximum will be the freezing point. Okay. Okay, here it is given as just begins to precipitate. So by using the SO4 concentration, 1 molarity, 50 ml of 1 molarity, okay, of unknown solution is added to BaSO4. Final volume is 500 ml. So final concentration will be 50 into 0.1 moles divided by final volume will be 500. So that means sulfate ion concentration is 0.1. So when you put the sulfate ion concentration in BaSO4, you will get the barium concentration 0.9. Okay. Now here initially it is already there. Final volume is 500. Okay. So by using M1V1 equal to M2V2, you have to answer for the M2. M2 you will get as a 1.1 into 10 to the power of minus 9. Okay. 550 is the final volume. 50 ml of is added to 500 ml. Okay. So therefore answer will be 5. According to 550 you will get 1.1 and volume increase. Therefore this will remain same 550 only. Okay. Therefore 10 to the power of minus 9. Okay. Answer is D option. Note down the solution carefully. It is advanced question and more than one correct. Okay. If you read carefully, you can answer. The problem is not with the question. Problem is with the patience. With patience, if you read, then answer A and answer D will be correct. Okay. So I will explain, don't worry. So intermolecular attraction between here, this graph you have to study it carefully. So let me check. A solution formed by mixing two liquids, L and M. Okay. Here on this, we are taking X upon M. I think you remember, normally on the graph, we will take both mole fractions, L and M. So here Xm is 0. So Xm is equal to 1. So that means XL will be 0. Okay. So accordingly, they constructed a graph. Actually, if it is ideal, then it should be straight line like this. If it is ideal, then it should be straight line like this. Okay. So pressure of L plotted against this mole. Once mole fraction is here, this is mole fraction of M, and here pressure of L. So mole fraction of 1 is pressure is 0 because mole fraction of L will be 0. Okay. Xm represents the mole fraction and L, the correct statement. The attractive intermolecular forces between L and L and M in pure liquid are stronger. See, this line, whatever I have drawn, I will draw it the other way. So here you can say some side it is positive deviation, somewhere it is negative deviation. See here, okay. So because of that, some positive deviation, I will mark it here. Here this is a positive deviation. Here there is a negative deviation. Only thing, normally we study in the every graph either positive or negative. Here they combine both of them like this. Okay, up to here positive deviation, up to here negative deviation. Accordingly, positive deviation means higher pressure. I will write it here. When pressure is higher, attraction forces are lower. So accordingly, A and D will be correct. Up to here what and after this what. That is what given in the A and D options. Okay. Okay. Next, freezing point of benzene decreases by similar type. We got it in the Ames also. 2 grams of acetic acid, 20 grams of benzene. If acetic acid associate, this is very important thing. See, acetic acid only, but acetic acid will dimerize or dissociate, that depends upon the solvent. Okay, when the solvent is water, then it will dissociate. Okay, when solvent is water, then what it will do? It will dissociate, and dissociate means I will be greater than 1. When the same acetic acid but dissolved in the benzene, then it will associate. Okay, so that time I will be less than 1. Here it is given as uh, acetic acid in benzene, so associates to form dimer. Percentage ionization, percentage association you have to find out. Okay. Okay, here is a solution. Dimerization, two molecules are converting into one. What is the difference between dimerization and finding the I value? For dissociation, finding the I value, we have shortcuts in the end of the session of the one shot lecture or in the last lecture of the solution chapter. Okay. So alpha is equal to 94.6%. Let us see which option is correct. 94.6% means A option is correct. Okay, now let's see the next one. One question is theory based, another question is numerical. So first solve the numerical but easier one. 2016 mains question. Okay, here it is C6H12O6 actually. You can take as per the slide. Okay, aqua solution, 18 grams of aqua solution. And here vapor pressure of water for this. That means solution vapor pressure only you have to find out. Okay, very simple question. You will get to 752.4. Okay, now tell me the next question. Actually, here also one print mistake is there. Carbon tetrachloride. This is carbon tetrahedral, it is not there, CCl4. Okay, so I will tell you how to solve this type of question. Methanol, suppose this is methanol, okay, and this is another methanol. So when two methanol are there, there will be hydrogen bonding. Okay. So there will be hydrogen bonding. But when you put carbon tetrachloride, CCl4, then this bond will break. So this molecule will move far away, this molecule will move far away. Volume will increase, so positive deviation. Okay. Wherever hydrogen bond breaks, that will be positive deviation. Okay. Same happens here also in acetone and carbon disulfide. Okay, toluene there is no hydrogen bond. Aniline there is a before also after also hydrogen bond will be there. So answer will be A comma B. Answers are A B. Okay, next question. Speed up. Paper 2 advanced question. Okay, first answer is correct. 724. Okay, next. Try the next one. Okay, here answer will be B. What is the answer? Answer is B. If you got that answer, then you are correct. Okay, that's all. I think all models are covered because we have covered the aims, need, and mains and advance. Okay, all the best for your exams. And if you have any problem in any topic, go through the topic lecture or one short revision that is as per you or DPP session. All facilities are there. You avail as per your own problem.